Good morning, ladies and gentlemen. Welcome to this exceptionally long video on the answers of 3G. Now, I'll try not to make a mistake, and I will try and work through this relatively rapidly. Please don't watch this entire thing. The idea is you guys will try the questions. You might get half of them right for those who don't, or those you miss. Scroll through this video until you find me answering the question, and hopefully me talking it through will be useful. Jumping in here at question 4, because it's the first sort of more challenging one. Let's have a read through. All right. A manufacturer of electric kettles performs a cost control study. They discover that to produce X kettles per day, the cost per kettle is given by something with a minimum production capacity of 10 kettles per day. So realistically, that's telling us the domain is greater than or equal to 10. So we're only really considering answers above 10. How many kettles should be manufactured to keep the cost per kettle to a minimum? All right. Anytime we're thinking minimum, we're thinking, all right, I need to find dy dx or f of x, and I want a neg plus happening on the sine diagram. And that's our aim. Basically, find where is that negative plus so we get the minimum. So let's find c dash x. C dash x is 4 on x plus. Now, frankly, I would probably expand this out. That squared is going to hit the top and the bottom. So it is going to be 900 take 60x plus x squared on 100, which is equal to 9 minus 6, well, I'm going to go 60 on 100, x plus x squared on 100. So, to derive that, the 9 disappears, that goes into minus 660 on 100 rather, and then this goes plus 2x on 100. Alright, so I've done that in a couple of steps. It's not particularly pretty, but I would expand this out, recognizing that is the same as this. And then when it's a polynomial all cut up into chunks, it makes it relatively easy to derive. Alright, then we want to set this to equal to 0. 0 equals 4 on x minus, I'm just going to write that as 6 on 10 plus x on 50. I hope you'll forgive me for doing that simplification. I'm not even convinced it actually made things simpler. I'm going to multiply through, basically, fractions are hideous, don't like any of them. I'm going to multiply through by x, and at the same time, I'm going to multiply through by 50. So basically, I'm multiplying by 50x. 0 equals, this by 50x is 4 times 50 is 200, minus this by 50x, well, 6 times 50 is 300, divided by 10 is 30, and there's an x there as well. And then this by 50x will just be x squared. And really, this is x squared take 30x plus 200 equals 0. All right. Now, for the sake of brevity, we're going to go with calculator, clearly quadratic formula. Heck, probably even factorization might work. But menu, equation, polynomial, degree 2. What is it? 1, 30. Oh, neg 30, 200. Good to know. Neg 30, 200. All right, 20 and 10. Minimum production of 10 per day. We're probably going to eliminate minimum. We'll say x is equal to 20 per day is the minimum. Our sine diagram, therefore, is going to be 10, 20 for x of f of x. And we substitute numbers in. As we substitute numbers in, we should find that's negative, that's positive, giving us a minimum cost here at x equals 20 kettles. Also, I really hope I'm getting these right because I'm not doing maths as I go. Alright, infinitely many rectangles which sit on the x-axis can be inscribed under the curve e to the minus x squared, as shown. Determine the coordinates of C such that the rectangle ABCD has maximum area. Alright, I would take out A, B, C, D. and probably draw a little better than me. And I would recognize that the coordinates of C are going to be, C is the point x across e to the minus x squared up at that particular point. And it's variable, so clearly we can make C up here and make this like long, thin rectangle. This is how high up it is. How high up it is also the length of that side. That is this side, is this height. This length here, 2AD, sorry, AD is there. If I'm calling that x, the entire length is 2x. So if I'm maximizing area and I'm thinking rectangle, well, I know that area of a rectangle is length times width. Area of a rectangle is 2x, which is my length, times width, which is e to the minus x squared. Now I want to maximize it. So setting the first derivative to 0, finding where that setting point is. Slope up, slope down. Alright, now I need, well, dA, dx, or a dash. A dash here we're going to get with quotient rule. Not quotient rule, product rule. U equals 2x. B equals e to the minus x squared. U dash is 2. V dash is minus 2x e to the minus x squared. Alright, and therefore a dash is u dash v, 2e to the minus x squared plus uv dash 2x dot minus 2x e to the minus x squared. Alright, a bit ugly, but we want to set it equal to 0. 0 equals 2e to the minus x squared plus, actually, because of that negative there, it's going to be minus 4x squared e to the minus x squared. Alright, now here, I would be recognizing that you have a pair of e to the minus x squareds and a factor of 2 that can both be factorized out. Therefore, 0 equals 2e to the minus x squared, bracket 1 take 4x squared. Interesting. We still want it to equal 0, and I might remind you that anytime you see 1, you can really think of it as 1 squared. And I want to think of this really as 2x all squared. The reason I'm thinking of that is because then I can use difference of perfect squares to factorize. 1 take 2x, 1 plus 2x. Alright? The reason this works out so nicely is because it lets us almost see our solutions. There are no solutions from there. That will never equal 0. E to the anything won't equal 0. The solutions will come from here. They'll come from 1 take 2x is equal to 0, and 1 plus 2x is equal to 0. And these answers are x is minus a half, and x is positive a half. So to fully answer the question, the coordinates of C are a half e to the minus a half squared, and C is minus a half e to the minus a half squared. And you might be thinking those two are the same because minus a half just makes it positive, and you're absolutely right, they should be the same. That will be this height here. And the fact we've got two solutions of positive a half and negative a half kind of makes sense, because it doesn't matter if C is there or if we reverse the entire triangle and C lands out here anyway, lands out here where B is. Alright, so, nice one. Alright, 6. A circular piece of tin plate with a radius of 10 has 3 segments removed as illustrated. The angle theta is measured in radians. Alright, this one requires you to remember a few key things. Firstly, a segment. So area of a segment. Now, if I told you the segment was half a circle, you'd be like, okay, a circle is pi r squared, and that's half a circle. You could also say a quarter of a circle is a quarter pi r squared. The great news about area of a segment formula is it's quite flexible. In degrees, it's theta on 360. Very simply, if you let theta equal 180, well, you have that fraction and a half we just had before. If you let theta equal 90, you have that quarter circle we had before. However, here we're talking in radians. We still want the fraction argument, and we remember there are 2 pi radians in a fraction, and therefore this is theta on 2 pi. Now, interestingly, the pi's cancel, and so therefore the area of the segment is theta r over 2. And that is section 1. Alright, now there's a couple of different ways we can break this up. So what we're trying to do is find an area. Second rule you should know is from a non-right angled trig is the sine area rule. Remember, for a generic non-right angled triangle, if you have A, B, C, and angles C, A, B, the area of that is a half AB sine C. And if you don't remember the letters exactly, the important thing is to know that AB are the ones either side of that angle. And that gives you the area of a non-right angled triangle. Alright. So I'm just going to continue these out. And if I've continued that line correctly, and we're talking region 2 here, I'm hopeful you'll be happy that this is also a theta, because they're vertically opposite. And that this is 10 and 10 because they are radius lines. And therefore the area of section 2 is a half 10 times 10 times sine theta, which is a half, which is 550 sine theta. Alright, so we have area for number 1, area for number 2, and then 3 is a bit of a repeat. Using the same logic as area 2, I can say area 3 is a half 10 dot 10 dot sine pi take theta. Now, pi take theta is from this entire thing being pi, taking the theta off. Remembering 180 degrees is pi, taking theta off, we have pi take theta. Then, unit circle. If this here is theta, pi take theta is going to have the same height. Because of this, we can say that sine theta is equal to sine pi take theta. So this portion here is sine of pi take theta, meaning the third area is equal to 50 sine theta. Alright, so bringing it together, I have area 1 plus area 2 plus 2 lots of area 3. I have theta r squared on 2 plus 50 sine theta plus 2 lots of 50, so I hope you'll forgive me and let me say 100 sine theta. And that is our total area. Now, it's not quite what we're after so far. Let's bring that a little closer together. Alright. Area equals, that r is really 10. 10 squared is 100 divided by 50, so it's divided by 2 is 50. Theta plus 150 sine theta. Let's factor out 50. Area is 50 bracket theta plus 3 sine theta. Alright, which is exactly what we wanted. Nice. Now, we need a ton more space. We want to say when the area is maximized. So once again, we find first derivative, we solve it equals 0, and we draw a sine diagram to show it's a maximum. So a dash. Frankly, I would just expand that right back out again. Area equals 50 theta plus 150 sine theta. Yeah, you could do a chain rule or product rule or something, but this is way better. Therefore, a dash equals 50 plus sine goes to cos, so 150 cos theta. We want to set it equal to 0. 50 plus 150 cos theta. Take 50, divide by 150 equals cos theta. And we're looking for cos theta equals minus a third. All right, then we can reach for our calculator to give us an idea. But we should also be thinking unit circle. So unit circle, cos theta is minus a third. So cos is negative on the left-hand side, minus a third. We're thinking, well, 1 on 3 here. And then we draw an angle here, and recognizing there's an angle here, there could be 2 solutions. And then we want this side to be 1, and this side to be a third, and there to be theta. I was saying, at this point here, you look on your cheat sheet, which will have all those special identities, and you'll hunt around here for an x of minus a third. And it doesn't happen. There's no special angle cos that would give us minus a third. So we go to plan B. Plan B is to graph it. Cos x minus a third, you want to know when they're equal. Great. Graph it, desolve, intersect. Now, we probably don't want a negative angle, so I don't like the negative, but I do like this one. We don't want that, because 4 radians is way too much. So 1.91. Right. X is approximately equal to theta is approximately equal to 1.91 radians. And that is our only feasible solution. Sometimes these will work out nicely. If they're nice, useful to have this table, we'll probably come back to it. Otherwise, it's something that you need to grab your calculator for. And you can either use solver, but solver won't necessarily get the correct domain. Best option is just graph both. Graph the line cos x and graph the line y equals minus a third. Watch where they intersect. All right, question 7. A new anesthetic is administered. Oh, Sine diagram. You got that. All right, is administered. The effect is modeled by e to the TET equals 750t multiplied by e to the minus 1.5t, where t is greater than 0 in time in hours after the ejection. Find e dash t. All right, product rule. U is 750t. V is e to the minus 1.5t. U dash is 750. V dash is minus 1.5 e to the minus 1.5 t. Alright, so therefore e dash t is u dash v, 750 e to the minus 1.5 t plus 750 t multiplied by minus 1.5 e to the minus 1.5 t. Alright, what time was it most effective? We're thinking maximum. Buy ourselves some more space. If we're after maximum, we'll factor out something and make it equal to 0. 0 equals, we'll factor out 750 e to the minus 1.5 t. Bracket 1. Let me see, 750 is out, so is minus 1.5, so is e to the minus 1.5 t. So really we have minus 1.5 t left. Yeah, don't think I missed anything. All right, this first portion will never give us a 0. The second portion, though, can give us a 0. 1.5 t equals 0. Take 1, divided by 1.5. T is 1 over 1.5, or another way of looking at that is 2 on 3. That will be the time where it's maximum, and we can check that by doing 2 on 3 et t sub in 0, and we're going to get a positive, sub in 1, and we're going to get a negative. Alright, a symmetrical gutter is made from a sheet 30 centimeters wide by bending it twice as shown. Deduce that the cross-sectional area of the gutter is given by 100 theta bracket 1 plus sine theta. Alright. So this was 30 centimeters, meaning that's 10 as well. Alright, so we need to find, I guess, a couple of sections. First section 1. Okay, the area of 1 is length times width. Now, length is easy enough. I'm going to call length 10. Height is a bit harder. Height is this number here. So if I think about that, I have a theta and I have a 10, and I want to find this height here, which I'm just going to call h. What relates them is the fact that there is a right angle here, and I can use SOHCAHTOA. So I still had written on my math sheet when I finished year 12, SOHCAHTOA at the top. The reason it's important is because what I've got here is an adjacent and a hypotenuse and an angle. A and h is cos, therefore cos theta is equal to adjacent over hypotenuse. H is equal to 10 cos theta. Therefore, the area of that big section is 10 times 10 cos theta is equal to 100 cos theta. Alright, good place to start. Now, let's find the area of a triangle. If we're calling this shape 2, the area of a triangle. Well, in fact, we're going to multiply it by 2, but okay, let's just do a triangle anyway to start. Is base times height on 2. Now, the height is already solved. That's that height. It's there. It's this. So what about the base? Well, base is going to be the opposite side. Base will be 10 sine theta. So therefore, the area is going to be 10 cos theta multiplied by 10 sine theta over 2. Now, because shape 2 is really 2 halves of a triangle, we're going to multiply it by 2 and therefore really get rid of this 2. And therefore, the area for the 2 triangle portions is going to be 100 cos theta sine theta. Therefore, the entire area total, is 100 cos theta, which will be the box, plus 100 cos theta sine theta, which is going to be the triangles. And then to simplify that a little, we are going to take out a common factor of 100 cos theta, and what we're left with is 1 plus sine theta, as required. Pretty neat. Show that dA d theta equals 0 when sine equals a half or minus 1. Interesting. Alright, so then we need to find the derivative of this. So the derivative is going to be 2 different things. We'll have u and v. I'm going to make this 100 cos theta and 1 plus sine theta. U dash, therefore, is minus 100 sine theta, and V dash is going to just be cos theta. All right, therefore, dA dt, with respect to time, just root of A, so we'll go A dash, is U dash V minus 100 sine theta bracket 1 plus sine theta plus 100, well, cos theta times cos theta is cos squared theta. Alright, now from here, probably a couple of different things you can do. I would be pretty tempted to multiply that in. Minus 100 sine theta minus 100 sine theta squared plus 100 cos squared theta. Alright, the reason I'm tempted to multiply it in is because I'm remembering that cos squared theta plus sine squared theta equals 1. So maybe we can have a crack at that and manipulate this somehow to make that useful to us. And I think the best way to make it useful to us is just to put a big old bracket around it like that. Although that's not strictly allowed. Let me think. Alright, the reason that's not allowed is because previously the negative was just affecting the sine theta, and by throwing those brackets in randomly I made the negative hit everything, which is not good. So, new plan. We're going to rearrange this equation, and I'm going to recognize that cos squared theta is the same as 1 take sine squared theta. And what I'm thinking is, actually, I would like everything here to be in terms of sine. So that's what we're going to do. Instead of us having this cos squared theta on the end, I'm going to make a replacement. And I'm going to make a replacement based on the fact that 100 cos squared theta is equal to 100 bracket 1 take sine squared theta, which is the same as 100 minus 100 sine squared theta. Alright, so let's make that replacement. A dash is minus 100 sine theta minus 100 sine squared theta plus 100 minus 100 sine squared theta. Alright. Ooh, this is pretty hideous, isn't it? Alright. What I'm recognizing here is that I'm going to tidy it and rearrange the highest powers at the front. I think it's a quadratic in disguise. A quadratic in disguise meaning there's something squared, a single power of it, and then no lots of it. You'll see what I mean. Minus 200 sine squared theta minus 100 sine theta plus 100. Now, to let us get a bit of clean air, I'm going to take out minus 100 from all there. A dash is minus 100 bracket 2 sine squared theta plus sine theta minus 1. Now, this is definitely a quadratic in disguise here. You see how it's a single power squared, and then no lots of sine theta. When you get a quadratic in disguise, I would let A equal sine theta. And therefore, what you've got is minus 100 2A squared plus A take 1. And then we're looking to factorize. A dash equals minus 100 bracket. We want to factorize this portion in here. There's clearly got to be a 2A, and there's another A there. The only way to have a minus 1 at the end is to have a plus 1 and a minus 1 multiplied together. The only question is, where do they go? And the answer is plus 1 here. The reason I want a plus 1 there is because that is going to multiply with this to get plus 2A. And I'm going to put a minus 1 here. Minus A ends up with a positive inside. Alright, so there's that. This will equal 0 for minus 100 bracket 2A take A plus 1 when A equals minus 1 and A equals a half. But A is equal to sine theta, therefore our solutions are when sine theta equals a half and when sine theta equals minus 1. That was pretty satisfying. Sweet. For what value of A we've got to have a maximum carrying capacity? Alright, so we have got a sine diagram with little arrows on the end, a 1/2 here, a minus 1 there. And we want to find the value for theta for which this is a maximum. Alright, so we're going to have to do some substitutions. We're going to substitute a value up above here, so maybe 1, a value of in between, 0, and a value in here, minus 2. And we are going to substitute them into this equation here. Now note, this is actually just doing it with A for now. We haven't solved it yet. I just want to find which one to solve for, and it's much easier to do it with A than it is to do it with theta. Alright, so if I sub in 1 here, it'll be positive, positive, and a negative at the end, so negative. If I sub in 0, it'll be positive, negative, negative, so positive. If I sub in minus 2, it'll be negative, 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 3 negatives is negative. And so we're looking for a maximum, that's doing that, that's doing that. The maximum is occurring at sine theta equals a half. Sorry, sine theta equals a half is the max. Alright, so then we've got to think, well, what value of theta equals a half? What value of sine theta was a half? You can think unit circle. You can go up and drag that unit circle from above, but I think I actually remember this one. It's pi on 3, pi on 6. Theta equals pi on 6. I'll drag it. Alright, so drag down to here. Sine is the vertical. So you're looking at the y values. We wanted theta to be a half, so it's this one here, so pi on 6. Again, this is a very useful tool to have with you. Alright, next question. You can row a boat at 3 kilometers an hour and walk 6 kilometers an hour. He is currently on point P, he's there, on the shore of a lake of radius 2 kilometers. Cool. He will row to point Q and walk around the lake to point R, which is opposite. Show that PQ is 4 cos theta. PQ is 4 cos theta. Cool. Alright, to solve this, I'm going to use a neat property from circle geometry. if you have a circle and you cut across it with a chord, you can bisect that chord. Sorry, my pen has just gone very strange. Right, you have a chord and you bisect the chord. Don't know why my pen looks like my heart rate. I swear my hand's not shaking. Alright, the point is, when you bisect the chord, you get a right angle. So if I bisect that chord like this, amazing, I get a right angle there. And that's the right angle triangle I'm going to use. So I will draw it out here a little more neatly. Bisection. This is 2 because it's the radius, that's theta, and I'm really interested in this length here, which I'm just going to call x for now. Alright. Now, this is the adjacent, this is the hypotenuse of that circle, so therefore cos theta equals x on 2, x equals 2 cos theta. But because PQ equals 2x's, therefore PQ is 2 times 2 cos theta, which is the same as 4 cos theta. Alright, so that right there is 4 cos theta. Show that the time taken of user journey is given by time equals. Alright, so there's 2 portions of a circle here. 2 portions, I guess, to consider. There is the PQ portion and the QR portion. Time, oh, Tim's my name, time equals PQ plus the QR. The other thing to be noticed is that speed equals distance over time, and therefore time equals distance divided by speed. I can never remember the time on. I just go speed equals distance over time and then go there. Alright, so time equals distance divided by speed. So for the PQ portion, it's going to be the distance, which is 4 cos theta, divided by the speed in which he did it. He's rowing in that portion, so it's 3. 3. Alright, that's the PQ bit. Now the QR bit, I know the speed, I don't know the distance. So QR is that distance remaining around the circle there. Alright, once again, we're going to need some circle properties. Now, I'm not sure how many of you are going to be happy with this, but that will be 2 theta. Fun, huh? There's a couple of ways to think about this, or to sort of prove it to you, I guess. If that's theta, this will be theta as well, because it's an isosceles triangle. They're both radius lines. Therefore, this in terms of radians, or in terms of degrees, would be 180 take 2 theta, or would be pi take 2 theta. If that is pi take 2 theta, then this other one here must be 2 theta, because the whole thing must add up to pi, or 180. Anyway, that's 2 theta. Now, the circumference of a circle, a full circle, is pi r squared. The circumference for half a circle is half. The circumference for a quarter of a circle is a quarter. In degrees, I can think of this as theta on 360. So, for example, if this was 90, that would be a quarter of a circle. Sorry, what am I talking about? 2 pi r. Replace everything I said with a 2 pi r at the front because we're talking circumference on area. 90 on 360. Now, for a circle in radians, it is going to be something on 2 pi. So theta on 2 pi. Therefore, the circumference of a segment, so this portion here, is going to be, they cancel, the 2's cancel, is just theta r. which is a really neat outcome. Good one to have on your cheat sheet. So that theta r is that distance there. So that is the distance he travels is theta r. And the radius, remember, is 2. So his distance from the QR distance is 2 theta. And he rose at 3 kilometers per hour. No, because now he's walking. He walks at 6. So we're thinking 2 theta on 6, which is going to be the same as theta on 3. Which perhaps frustratingly isn't the right bit, because this in here is not a single theta. So it's not a single theta, it's 2 times 2 theta. This is where they are like them. In fact, they don't show that, so it's 4 theta on 6, which is the same as 2 theta on 3. Alright, so a lot there. And some interesting or useful things to know about a circle. The circumference of a segment will be theta r. Or you can go from first principles and remember that one. Alright, find dt d theta in the first quarter. Alright, I'm just going to take this, bring it down here, so we have a nice neat start. We want to derive it. So, d theta dash is minus 4 on 3 sine theta plus 2 on 3. And what do I want? It wanted to set it equal to 0. 0 equals minus 4 on 3 sine theta plus 2 on 3. I would multiply both sides by 3. 0 equals minus 4 sine theta plus 2. I would then drag the 2 over. Minus 2 divided by minus 4 equals sine theta equals a half. So we're looking for sine theta equal to a half, and we grab our unit circle. Voila, magic. Alright, unit circle. We want it equal to a half. Oh look, we did this one already. Theta equals 2 pi on 6. Now, note that it's equal to a half in another place, over here, at 5 pi on 6, but the question restricts the domain. We can't go more than a half pi, so just pi on 6. And then for our sine diagram, it would look like this. Pi on 6. And the rest should be pretty easy. And my brain's getting fried, so I'm not going to do those two and those two. Honestly, B is the hardest portion here. Alright, 9 done. Moving on. Question 10. Oh, I'm feeling a Pythag. Yes, there's got to be a Pythag here. Alright, a pump house to be placed at some point X along a river. Cool. Two pipelines will then connect the pump house from homesteads A and B. How far should X be so that the total length of the pipeline is minimized? Alright. So, how far should X be from M to the total length? Okay, the fact they've asked the distance X from M means I'm just going to let that be X. That means that when I find my solution for X, I've actually got the answer. This portion here then is 5 take X. If X was 3, that would be 2. Right, you don't know. Alright, so our total portion, total pipeline is this length plus that length. 2 squared plus x squared equals 1 squared. 1 is equal to the square root of 4 plus x squared. Same sort of logic. 2 is equal to the square root of 1 plus 5 take x squared. Alright, and basically we want to add them together and find the length such that it's minimized. Give me 1 second. All right, sorry about that. The plan from here is to add them together, and then we want to minimize them. So we are looking for, really, when does the square root of this and this, when is all that minimized? So that is our total distance. All right, so to find a minimum, we're going to differentiate, find equal to 0, sine diagram to confirm it's a minimum. Although, let's be honest, I'm probably going to skip that bit. All right, so we're going to set that equal to 0. First of all, we're going to differentiate it. I would write this as 4 plus x squared to a half, and I would write that as 1 plus, and honestly, I would probably expand this out. I would call that 25 and 1 is 26 minus 10x plus x squared to a half. All right, then if I was going to differentiate it, you can do them in portions. So the differentiated version, or d dash, is a half. 2x comes out. 4 plus x squared to minus a half plus a half bracket. 2x take 10 comes out. 26 take 10 x plus x squared to minus a half. There we go. All right, it's not particularly pretty. It's not pretty at all. Let's set equal to 0. 0 equals a half and 2 cancel. That's nice. So we have x over x plus 4 plus x squared square rooted plus a half can go into here, making that x take 5 over the square root of 26 take 10 x plus x squared. All right, now what about making that equal to 0? We really want one big fraction here, don't we? I can't see a perfect square. I can't see how to factorize the ones on the bottom. What I'm thinking is I'm going to combine it into one large fraction. All right, so if I'm going to combine it into one large fraction, 0 equals x for our square root 26 take 10x plus x squared plus x take 5. Whoa. X take 5. Lots of root 4 plus x squared over root 4 plus x squared root 26 minus 10x plus x squared. All right, the only way for that to equal 0 is for the top to equal 0. Therefore, 0 equals x square root 26 take 10x plus x squared plus x take 5 root 4 plus x squared. And there comes a point in problems where sometimes they're just meant to be done on a calculator. I'm sure there is an elegant algebraic way of doing this, but it doesn't immediately apparent, and a calculator is a legitimate answer. So before going into a calculator mode, I would suggest thinking, what is a reasonable solution? If you look at this, we want some sort of solution between 0 and 5, probably slightly more than halfway because we want it slightly towards the 1 level to make it slightly lower. So how do you actually find this answer in the calculator? I would put the whole thing into graph mode. Here's one I did earlier. Into graph mode, you want it to equal 0, so draw it. If you like, it has one solution. Piece of root 3 1/3. X equals 3 1/3. Done. Probably kilometers given the scale. Alright, so bear in mind that for a good chunk of the exam, half of it, and for this entire set, you're going to have a calculator. Don't be afraid to use it when you get to a point that algebra clearly isn't going well. All right, onwards. Question 11. How many words go? 12, 13. Do this. All right, 11. A boat is 5 kilometers out to sea. Cool. AC is a straight line. OC is a straight sandy beach, rather 6 kilometers long. Peter can row at a rate of 8 kilometers per hour and run along the beach at 17 kilometers per hour. Well, Peter's quick. All right, suppose Peter rows directly from A to B, from B to X on AC, such that AX is X kilometers. Lovely. Explain why X is greater than or equal to 0 or less than or equal to 6. It's the length of the beach? Like he can't land off the beach? Whatever it is. So the total time Peter takes to row X and then run along the beach to C is given by. Alright, so remember, time, I can never remember, right? A good one to have on your triangle is speed equals distance over time. Have you guys seen this triangle? If you want time, highlight it, and then the remaining 2 is distance over speed. Alright, now the question has given us the speeds in each case for each leg of his journey. It hasn't given us the distance, so we're going to find distance here. Alright, this distance here comes from Pythag. So bx, basically bx, I think squared is 25 plus x squared, or 5 squared plus x squared. So bx is the square root of 25 plus x squared, meaning the time for bx is equal to the square root of 25 plus x squared over the speed at which he did it, which he's rowing a boat, which is 8. Alright, so then let's look at this other one. If that is x, this portion here must be 6 take x. Alright, so if it's 6 take x, that is the distance, it's that length, divided by s, which is his speed. So the time for xc is 6 take x on 17. And the total is adding those 2 together, which is what is shown there. Pretty nice. Alright, given that x is between 0 and 6. Find x such that dt equals 0. Explain the significance. Well, the significance is this will be the shortest time that it will take him. So, let's find that. If we have the square root of 25 plus x squared on 8 plus 6 take x on 17, and that is t, dt dx is going to be a half 25 plus x squared to a minus a half times 2x over 8 plus, well, minus 1 on 17. I would think of this as 6 on 17 minus x on 17. You can split it like that in a fraction. When you differentiate this first one, it disappears. When you differentiate that, it turns into the minus 1 on 17. Alright? So then we want 0 to equal that 2 and that half cancel. Basically, this is x over 8 root 25 plus x squared minus 1 on 17. Alright. Let's be honest, calculator is probably an excellent shot here. If you want to skip the next minute to 5 minutes of the video, by all means grab calculator. Otherwise, let's try a shot at this. 1 on 17 equals x on 8 root 25 plus x squared. Let's try cross multiplying. 8 root 25 on x squared equals 17x. We need more space. I would divide both sides by 8. Square root 25 plus x squared equals 17 on 8x. I would then square both sides. 25 plus x squared equals 17 on 8x squared. Pretty savage. 25 plus x squared equals 17 squared on 8 squared. Ugh, grab a calculator. 17, the whole point of this is not to do a calculator. 289 on 64. 289x squared on 64. $25 equals 289x squared on 64. Take 64x squared on 64. So I've just moved that x squared over and made it have a common denominator. 89 take 64 is 225. Actually, that works out all right. 25 equals 225x squared on 64. I would multiply both sides by 64. So 64 times 25 is 1,600 equals 225x squared. Divide that by 225. 1,600 divided by 225. Oh, that doesn't work out so nicely. I would then divide it by 2.5 by doing 1,600 over 225 equals x squared. Therefore, x equals plus or minus the square root of 1,600 over 225, which equals square root of 1,600 is what, 40? Plus or minus 40 over root 225. I feel like 15, but we'll figure that out. Root 225. Hey, I can still math. Equals 15. Plus or minus root 40 on, sorry, plus or minus 40 on 15. The issue is the negative. You can't really have a negative. We had to be positive, so we're just going to eliminate that answer. Our answer is 40 on 15, which is what, like 2 and a bit, 2 2/3. Then that is the distance he should land along the beach to minimize his total time. All right, question 12. A company constructs rectangular seating arrangements for pop concerts on sport grounds. The oval shown has the equation x squared on a squared plus y squared on b squared equals 1, where a and b are the lengths of the semi-major axis and the semi-minor axis. All right. Show that y equals that. All right, so what they're basically asking us to do is take this equation and rearrange it to get y by itself, because we don't do implicit differentiation. X squared on a squared plus y squared on b squared equals 1. All right, we need to get y by itself. So y squared on b squared equals 1. Take x squared on a squared. Y squared equals, to multiply the b squared up, b squared take b squared x squared on a squared. All right, note the endpoint. I have probably done the wrong thing then. I'd probably write this as b squared bracket 1 take x squared on a squared, and therefore square root it. Y is plus or minus the square root of b squared bracket 1 take x squared on a squared. which, frustratingly enough, is close but no cigar. Like, we're close, but it's just not quite what they're after. Alright, so to help us get what we're after, let's think 1 take x squared on a squared. If I take out a factor, and it's going to seem like a funny factor to take out, of 1 on a squared, I'm left with a squared take x squared. Now you might be like, why on earth are you doing that? And are you even allowed to do that? Well, heck, I'm allowed to do it. Imagine what happens if I multiplied this in here, this in here. If I multiplied those in, 1 on a squared times a squared is just going to give me the 1. 1 on a squared times minus x squared is going to give me minus x squared on a squared. I'm certainly allowed to do it. The reason I'm after it is because then I can write it as this. Y equals plus or minus the square root of b squared on a squared bracket a squared take x squared. And I'll put another square root in, getting tired. Bracket. Which is what we've got. That square root's going to hit the top there and knock them out, and then we're all good. But I'll acknowledge it's an odd way to go about it. Alright. Y. So that the area is given by AX equals this. Alright. So the area for the seating is going to be given by this X value, doubled, so 2X. Area equals 2X multiplied by Y. And Y is exactly what we've got there. So area is 2x multiplied by b on a bracket square root, don't even need the bracket, b on a squared take x squared. Oh, and I've made a mistake, because really it's not just y high, because that's that high. It should be 2y, which actually doesn't change anything, it just throws another 2 in here for us to play with. So then the area is 2 times that, now read to, is 4x. B on a root a squared take x squared. Alright, which is what they're after. Nice. The seating area is maximized when x equals a on root 2. Alright. So, same, I guess, plan as before. I'm going to cut this separately. We are going to differentiate. Find a solution for when x equals, or when the derivative equals 0. Lovely. Alright. Ignoring that one on the bottom. Alright. This one seems like an odd one to differentiate, but fundamentally it is 2 functions of x multiplied by each other. So it's product rule. U equals 4bx on a, and therefore u dash is just 4b on a. V is a squared take x squared to a half. And v dash is minus 2x times a half, which is just minus x, bracket a squared take x squared to minus a half. Therefore, the derivative, a dash, is u dash v, 4b on a, bracket a squared take x squared to a half, plus 4bx on a a multiplied by minus x bracket a squared take x squared to the minus a half. Alright, we need a little bit of tidying here. Quite a bit of tidying. A equals 4b root a squared take x squared on a plus. Actually, that road minus the front's going to turn this into a minus 4bx squared on a. Now I can either express this part as the top or as the bottom. And I actually think I want to keep it on the top. Keep it on the top with a minus a half. The reason I want to do that is now I have a common denominator. And everything's better with a common denominator, right? So I'm going to take out everything I can, which is 4b on a. If I take out 4b on a, I have a squared take x squared minus x squared bracket a squared take x squared to the minus a half. Alright. At this point I should be aiming for the fact that this a dash is actually going to equal 0. And note, this portion here is a constant. It'll never equal 0. Something here to equal 0, we're going to have to make x. Something will have to happen with x to make it equal to 0. So let's try step it up. Bear in mind, we do actually know our answer. It's going to be x on root a on root 2. We need to get a solution for this from inside that large set of brackets. Alright, 0 equals 4b on a bracket. Root a squared take x squared minus, well, x squared on a squared take x squared to a half. Alright, the reason I've written this slightly oddly is because I want to try and get a common denominator. Imagine I want to get x to a half on the bottom. I'm going to make this, instead of currently being a half, 1 over a squared take x squared to a half. If you're not convinced that I'm allowed to do that, imagine root a. Root a on 1 is the same as a on root a, because a to a half on 1 is the same as a to the 1 on a to the half, because the powers subtract to get back to there. So, what I've done from here to here is effectively that to that. It looks weird, but it's a neat trick because it gets me that common denominator. 0 equals 4b on a bracket. Now on the top, a squared take 2x squared over a squared take x squared to a half. Alright, we're getting somewhere. Note, the only time we can get a solution is when the top is equal to 0. So really, this is what we're interested in. So therefore, I can almost drop everything else off and say 0 equals a squared minus 2x squared. And here we want to get x entirely by itself. So minus a squared equals minus 2x squared. Divide both out by minus 2. A squared on 2 equals x squared. X equals plus or minus the square root of a squared on 2 equals plus or minus a on 2. Which worked out pretty neatly. Now note A is a distance, and therefore A cannot be negative, so we're just going to ignore that second part of the answer. And to fully prove it, we would have to do a Sine diagram, and to prove the distance back to maximum. I meant root 2. Root 2, definitely on the bottom. Alright, last one. It's in red. Give me a second to have a drink. Alrighty, so let's break this into two chunks. The length of AB, or my screen is closing up nicely. Alright, the length of AB, I'm going to say is actually two triangles. And I'm just going to invent a point called M, which is vaguely in the middle, even though I know it's not the midpoint. Alright, so let's take out one triangle separately off to one side and just consider AM. AM, and I'm hoping you're happy if that's theta. This will be theta as well. So we have theta and 3. And then I want, well, what will be the hypotenuse? I have my adjacent and I have my hypotenuse. A and H is car. So I know that cos theta is equal to adjacent over hypotenuse. My adjacent is 3. So if I want the hypotenuse multiplied by H divided by cos theta, H is equal to 3 on cos theta. So that gap there is 3 on cos theta. Nice. Let's consider the second portion, doing in red. 2 theta. I still want H. This is now the opposite. O and H is sine. So sine theta equals opposite over hypotenuse multiplied by H. Remember that the opposite is actually 2 multiplied by H divided by 2. So this H is equal to 2 on sine theta. That one there is 2 on sine theta. So the total length is the addition of those two. 3 on sine theta plus 2 on sine theta. Neat, huh? Alright, next up. Show that dl on d theta equals 0 when theta equals that. And note, interestingly, they've got it in degrees, not radians. So make sure when we grab our calculator, we reset it to be degrees after. Alright. So, I just stepped aside and did it on a sheet of paper. It's fun. It's a good one. You guys ready? Note that because we have to show this, we can't just jump to there, so we can't do it directly in a calculator. We actually have to prove that theta is equal to the inverse tan of the cube root of 2 on 3. So let's go. We start with 3 cos minus 1 theta. I'm just going to write theta like that. Plus 2 sine minus 1 theta. And that's L. Now, I hope you don't mind me writing it as minus 1 bringing it to the top. It helps with differentiating. Alright, so dl d theta. dl d theta. dl d theta. When we're differentiating cos neg 1 theta, that goes to minus cos neg 2 theta multiplied by the derivative of the inner, which is minus sine theta. Alright, because if you think of this as u to the neg 1, that will go to minus u to the neg 2 dot du. And du, the derivative of cos theta is minus sine theta. So over here, that is going to be 3 multiplied by minus cos to the minus 2 theta multiplied by minus sine theta. I'll tidy it up in the next line. Plus, same sort of logic on sine. Minus 2 sine to the neg 2 theta dot cos theta. Alright, let's do that tidying that I promised. dl d theta equals, now there's some negatives here, that negative and that negative cancel. And we're going to be left with, and I'm going to drop this down the bottom. 3 sine theta on cos squared theta plus, actually, minus 2 cos theta over sine squared theta. Now, quick aside, you guys will need to remember that tan theta is sine theta on cos theta. That'll be important in a second. Alright, so then we set it equal to 0. 0 equals 3 sine theta on cos squared theta minus 2 cos theta on sine squared theta. Alright, at this point, you can have a couple of different things. I would add the right-hand term to the left-hand side to make this 2 cos theta on sine squared theta equals 3 sine theta on cos squared theta. Alright, from here, I would multiply both sides by sine squared theta, and I'm also going to multiply both sides by cos squared theta. The effect of that is to have 2 cos 3 theta equals 3 sine 3 theta. That 3 at the top is cubed. What's really kind of happening is that's going up there, that's going up there, but the process is that double multiplication. Alright, so what's happening here is, remember how I said tan is sine on cos? I'm going to divide both sides here by cos cubed theta. This just becomes 2. This becomes 3 sine cubed theta on cos cubed theta. Now, sine cubed theta on cos cubed theta is sine theta on cos theta cubed, which is the same as tan theta cubed. So 2 equals 3 tan cubed theta. 2 over 3 equals tan cubed theta. Cube root both sides. The cube root of 2 on 3 equals tan cubed theta. Find the, we don't need the cube anymore, tan theta. Inverse tan. Theta is the inverse tan of the cube root of 2 on 3. Tick. And we are done.